had a customer ask us about what process or whatever we go through for matching drivers on the headphones. And it's a good question. It's a complicated question. It's not like, you just take the headphone and throw it on a test dummy head and go, yep, everything's good, ship it. There's a lot of steps that come way before that, before the final product's made. It's not really that simple. But yeah, we could talk about it a little bit,
It is a surprisingly complicated process. What I see other manufacturers advertising more or less is they effectively have software set up to take a driver, characterize it, and then bin and match various drivers together. And there's reasons for that approach. They're totally sound, no issues with it, but that seems to be a bit of a different approach than what we went to. We go to pretty moderately significant lengths to effectively build in certainty to the product before it arrives at that stage. There's a lot of things you could do to have a product measure good, but it isn't necessarily good. And that you could claim that's a fault of the measurement system, and to some extent it's true, but there's a lot of things you don't necessarily know, and you can't observe outwardly unless you dismantle or you understand the inner workings.
Yeah, well, and I mean, primarily because the simple acoustic measurement on a microphone or a test head is not really everything people are concerned about. I mean, in terms of a product, I mean, you've got to look at the reliability of the design itself, the mechanical function of it. Is it going to fall apart or is it going to hold together? It's more than just the sound quality. And all that does affect the sound quality. So you've got to pay attention to the assembly process and the parts and the quality of the parts. It's all a sum of the whole. It's a sum of the parts creates the whole.
Well, yeah, it's after years of making the parts, we still are finding like a thing. Oh, probably should measure this now. We keep adding things to the list so we're sure by the end that you have a good part,
Yeah.
And I mean, then taking into account like paint thicknesses and everything, that was a whole problem, because like, all right, we know the parts are right, but then if you have variation between two parts and the paint thicknesses are different, they're sprayed differently, then it won't work too. So there's a lot of variables.
And sometimes we redesign the parts to make it easier to make a good part reliably, because occasionally you'll have an issue in one particular spot, and you could design it out by changing the way the part's designed so that effectively the human factor produces a desirable part every time.
It allows for the variation in the human factor on the various assembly processes or coatings.
It mitigates the risk, yeah.
Yeah, right. Where everything fits together properly and tightly, even given some variation. It's a process you learn over years of doing it. Really, it doesn't happen on the first go around.
It is very difficult because if you think about it critically, you have the best measurement system known, and it measures everything perfectly, which isn't quite possible, but let's assume that that's the case. And you do every measurement possible to characterize this driver perfectly, and you think you have a good driver. But how does that necessarily tell you whether or not it's going to be reliable, whether or not there's a fault in there? It doesn't necessarily tell you if there's something in there, a conductor per se, that is fatigued in some way, that got damaged during installation assembly, and it's going to fracture and produce shrapnel or debris that floats around in the driver and makes a noise. And in your quick 30-second or even 2-minute characterization, this doesn't occur. But after a week or 6 months, it does in the customer's hands. It doesn't tell you that in the measurement, right? So there's a lot of things like that where that type of deal, you need to be sure during the assembly stage that's not going to occur.
And even prior to that, I mean, you think about every part of the whole is looked at, QC'd, inspected, right down to every part. The magnets are inspected before they're used. They're measured before they're used. How many things do we look at before
it's a lot.
Anything's even assembled?
But even then, we have to have everything in the same room for at least a day to get acclimated at the same temperature, same humidity. We have to control the humidity because that's very important.
Yeah, the adhesives require humidity control.
And they don't work if.
So here in the winter, we're actually dumping humidity into the room. We've got a 240 volt wall mounted humidifier just to be able to set up the assembly area, to get the assembly area up to, the 45 to 50% range. Otherwise, it'd be sitting at 25 or 30 here in the northern climates.
Yep.
The adhesives don't work properly at that.
All these things are monitored and logged.
Yeah.
We try to ensure that over the entirety of this this particular apparatus's existence, it's exposed to consistent temperature and humidity if possible to mitigate risks. And for some of the things, it doesn't matter. But some things are very sensitive to this, and it matters. And you'll see variation that you wouldn't expect. And it is surprisingly difficult to characterize these things. But it is indeed impactful when you're trying to ship a world-class product. If you want it to work right the first time, it's very important. Everything's as close to perfect as practical.
Yeah, metals you don't see, like aluminum. You don't see much.
Yeah, they don't really care
of
about
a tolerance
humidity.
on temperature. It requires
Well,
a
for
lot.
our purpose, it doesn't
Not
matter.
for us. Yeah,
Yeah.
right.
I mean,
For
it
some
does
things.
matter for something.
Yeah,
so.
right. But yeah, you don't see it. It doesn't. Expansion characteristics, its expansion and contraction characteristics versus temperature aren't as bad as, say, like a plastic or a polymer. Those could be dramatic. So if you're using those parts at different temperatures and so on, or you're not planning for that, and you're shipping it and it's 30 degrees out and it gets somewhere else and something let go.
Right.
It's
When you
simple things
assemble
like
the
that.
headphone,
Yeah.
it's 58, 62 degrees or something. It's unusually cold, and then it ships into a desert. You're going to see wild issues with tolerances
Yeah,
and the way
right.
the device is assembled. And some adhesives work and behave entirely differently with different temperatures, and most behave quite differently with humidity changes as well. And it can be really significant. And these are very big factors. And this is complicated because you could produce a thing that measures fine at the time it's manufactured, but then the conditions change when it's shipped to the customer. And now it's different. Now it's not the headphone you thought you shipped.
Right. Well, that's the thing with like adhesives and stuff. They have cure times of 48, 72 hours, but that's at a constant humidity and temperature. So
Yeah,
if you don't
certain
keep
spec.
it at that certain temperature, it could change if you measure it too early. Or it's
Which
not.
means you get variable results on
Yeah.
on the final assembly once it ships. And again, it's not something you could easily measure. Doesn't really show up in those type of ways. So anyway, these are the kind of things that as a manufacturer you learn over time. If you're paying attention to what your devices are doing out there in the field, you learn over time. And I can't think of anything really at this point. We've seen a few things come back with issues. But, I mean, for the most part, we've been lucky, actually. We've been very lucky and fortunate that we've thought a lot through before we ship a product, And particularly now we have so much time under our belt with making these headphones that, I think we kind of already foresee a problem before it occurs. It's engineered out. It's just part of our design process at this point,
You'd be surprised as a consumer the things that people will do to your products. And it can be very difficult to try to guess what people are going to do and ensure that it'll either tolerate that or be safe in that use case. Because people do all sorts of things that they really shouldn't. And the vast majority of people would laugh at you if you bring it up. Think, oh, no way someone would do that to a headphone that expensive. But people do plenty of weird things. And we need to think about them, understand what are the likely things people are going to subject this product to. How do we ensure that it tolerates it or mitigate the risk should something like this occur so that if it were to fail, it fails in a safe manner. You don't have pieces flying somewhere or something like that, because that could be an issue with some devices.
Yeah.
If you have something if you have a metal that is too hard, too brittle, it can crack and fracture and potentially either have small pieces that shoot everywhere, not like in a super dangerous manner, but potentially dangerous. And there's a lot of things you can do to mitigate that. If you change the design, you can design around the need, typically for such a steel, and you could get away with something that's annealed at a higher temperature, or something that's a little softer and more ductile and less likely to fracture.
In the end, anyone can abuse anything in any way, and really, ultimately you're going to cause damage if you think about it.
Yeah.
There isn't really anything in the planet that is abuse-proof. It's you'll find
Pretty
a
much.
way. If you want to abuse it, it's especially you deal with nice materials. Nice materials are nice materials, but they're they're nice materials, right?
Everything has a
You
limit.
could take a shirt and spend $100 on it, and it might be the finest cotton in the world.
Oh, it still gets
but you
stained.
could tear it real easy. Yeah, or stain it
gets
real easy.
Spaghetti sauce on you.
Yeah, or it's easy to just rip by accidentally putting it on the wrong way, or pulling it the wrong way.
Or like a dryer too hot, something shrink.
Or your cat snagging it, with their claws. So yeah, I mean, you think about it, it was a nice shirt until that occurs, and it's kind of the way it is with nicer materials. The nicer the materials they do tend to be a bit more fragile, versus a brick or concrete.
Yeah, but I think the important takeaway is that although it intrinsically seems obvious that you could measure and characterize something perfectly so that you need a match and where you could find a match for it and you don't need to worry about the assembly is important. Understanding how and why something's put together a particular way is critical to ensure long-term reliability, serviceability, and that the product doesn't change in the future, producing something that is no longer matched.
Yeah, and to wrap up the really discussion on matching in general too, is what we know is that, with our particular transducers and in terms of matching sound, right, they're pretty consistent across the board.
Well, that's the thing. Since we started in the beginning being tight tolerance, by the time they're in, it's not that hard to.
Yeah, they don't
get
vary
good.
from driver to driver.
Yeah.
I mean, other than impedance variations, which we match for, as the drivers are matched to the headphone. Impedance would be the biggest, I think, variation. We have a nominal impedance, and then it can vary a couple ohms plus or minus, and that would be more of a match in terms of what we're matching for. The frequency response and so on is extremely consistent from driver to driver. That's not even a friggin' issue. It's not, if it were, then every headphone would sound a little different from another one, and that isn't what you want. And so obviously as a manufacturer, that's something that it's baked in. It's already considered, that driver, those materials, the way it's assembled, the assembly, the precision of the assembly, it's from driver to driver is extremely tight. And you're not going to see a variation.
I think the last thing we implemented was monitoring temperature and humidity, data logging it, even when we're not here. Well, so like all month you can see when we're not here, like if it's colder outside, how much the HVAC is cycling and everything. So we're monitoring it all the time to know,
right,
what it's like just in that room.
Yeah, we keep our building. It doesn't vary a lot. Even when we're not here, we might drop it down 5 degrees to save energy, but no more because, again, we don't want to have a need to have to ramp up and wait for parts and components to warm.
Yeah, at least in the shop area.
Yeah,
so when we get here, everything's ready.
There are processes we know not to do first thing in the morning because we're going to
you got to wait for stabilization.
Yeah, right. Same with humidity. So yeah, we got this all down. It's a process. It's a procedure.
Took a while.
Yeah,
but
we got it down. And it's not like these things make dramatic differences in the end product. It's not like our products we made 5 years ago before we learned this suck or anything. It's just that we're constantly improving and looking at ways to make sure that everything is extremely consistent. Because honestly, in the end, it makes our job easier.
Yeah, that's what I was going to say. It just makes it easier on us.
Severely reduces any kind of warranty issues you might have or even out of warranty, right? I mean, we don't want people to have problems even 3 to 5 years out. We don't want them to have problems. So the whole process is designed to have this thing as reliable long-term as possible. And it works. It's worked for us. We don't, what do we get? A headphone a month maybe in for repair? What do we get? We don't see it. Even though we've been making headphones for 8 or 9 years now. So you think about that. I mean, it's pretty good. We've been pretty good straight out, and we're just gotten better over time in terms of the process. So, but that's who we are. That's what we do.
I think compared to most, we're a bit maybe a little over the top in some regards with the care and attention put into the way things are assembled. And I've always found that to be extremely important. If you don't assemble something the way it's always been done, you can't necessarily guarantee that the outcome is going to be the way you expect. And that doesn't mean you can't adapt and change, but it's very important to know why and how something was put together a particular way so you could ensure that it's repeatable, reliable. If you have different people putting the same part together, you need to carefully monitor them, make sure they're doing it the same way, because there's a lot of things that the end result could look the same, but it could perform differently. It could potentially have issues that were unforeseen. And understanding all these processes and the methods, the techniques used to ensure that you're doing it as close to perfect as possible is very important if you want a long-lasting product that is repeatable.
Well, yeah. I mean, being like assembling it yourself and working on the design helps out a lot. I mean, you know why it's done that way, and you know
Right.
how it's assembled, so you can design it for even better assembly in the future.
Yeah, I think in all manufacturing processes, they should always have the engineers try to put something together that they made, you know,
It's critical.
Yeah.
or even take it apart too, right?
Yeah.
Can you fix it? Like if it's something that should be fixed, you know, what's repairability like? You know, like some of these cars, like
Yeah.
you see these sportier cars where, you know, a line blows somewhere like a gas line, and you got to pull the engine to get at it, right? It's like, well, who the hell put that there, right?
Yeah, well,
Couldn't you think
it
of that?
worked on paper, right?
Yeah, right. It looked great. Yeah, it was a good space to
Yeah.
put in. According to, you know, on the screen, it looked
Well,
like a spot to put it.
A lot of people blame engineers for these things, and sometimes it's warranted. But I think knowing the likely things that you're going to need to touch and understanding the design in its entirety, so you could put the things that are more likely to be repaired or serviced in an accessible location, that's important. So having more hands-on with assembly in the engineering department seems to be a very wise choice,
Yeah,
if
or
possible,
disassembly.
because then at least they have a vague idea how this thing's going together, how it's being actually built, and maybe also build in a little bit of service too, so you could see when they come back, what do they look like? How did the customer use it, or potentially misuse? Look at the wear marks and stuff, and see, is it what you expected and predicted? What could you do to improve in the future?
I mean, I pick on cars, but they're very complicated devices. They have
Yeah,
tens
insanely
of thousands of parts, you know. So I get it. You know, you can't always think out everything, and you can't. Sometimes you don't have a choice. It's a design consideration
Well, and you got
for everything.
cost constraints and all that.
Yeah, totally.
Well,
totally.
sometimes there's also 50 departments working on it, and nobody told you anything. There's no communication between channels, so
Yeah,
you're just
right.
making a transmission.
Right.
You don't know where these hoses are going to line up, and sometimes, well, it's right next to the firewall, and you can't get access. But
Right.
whoopsie.
You know, something's got to change. Something's got to give at that point.
Yeah.
Yeah, there's
Yeah.
especially with vehicles, there's not too many that it's like one guy oversees every part of it, you know.
Yeah, it's impractical.
Well, not to mention you've got the cheese balls at the top saying we need to ship this thing.
Yeah,
This
right.
car needs to be ready to go by this month, you know. And at some point, that engineering ends, and you got to move out of that phase into production.
Well, I just heard I don't know, GM or something saying something like this. It's like when a new vehicle's released, it's like the engineers they're already on a new vehicle, so they're
Yeah.
like that's old,
Yeah,
like,
right.
but to everybody it's brand new, you know.
Right.
So they're like, yeah, we were dealing with that 5 years ago. You know?
Yeah, you design these things for years,
Yeah.
right? So by the time it ships, just I've been working on this thing for 3, 4, 5, 6 years, right?
Yeah, right.
It's old to you.
Yeah.
You don't want to look at it anymore.
Yeah.
That's right.
And it's a bit too late at that point to change it too.
Yeah,
That is the
right. It's
problem.
already shipping. The
The
tooling's been
wheels
made.
are
It's
moving.
being produced.
Yeah, which is probably why you see a lot of recalls and stuff like that on a lot of things. And it's it's stuff that you can't foresee everything. Not possible especially when you have that many disciplines coming together to put together a product. It's not possible. To
Well,
foresee
and stuff you
everything.
didn't even make, you know.
Yeah, right. Yeah. What the tens of thousands of vendors that make the tens of thousands of
Well,
parts.
a lot of the parts in the automotive industry, the manufacturer does not manufacture a great deal of them. But luckily in headphones, it is practical to some extent to have 1, 2, 3, 4 people have an extraordinarily in-depth understanding of the majority or the entirety of the product. And that's super beneficial. If you could get away with it, to have one singular individual know every particular item, why it's designed that way, and have an in-depth understanding of the market it's going to be used in, how the customers are going to use it, what abuse and neglect might occur to try to mitigate the risks from those in the design stage, that's super important. Then you could hopefully make a product that's easy to assemble, long-lasting, actually works well in the field, doesn't have issues. But of course, that's the dream. In reality, there's always something you forget about. There's always something you didn't expect. But you
Well,
hope you live and learn.
The other way to look at that is not that you didn't expect it, but somebody will find a way to break it. You know,
Pretty much, yeah.
and they didn't mean it. You know, it's not like they meant that. It just their kid got at it, or a dog at it, or something happened. Or it fell out the car door when they were going somewhere. Or who knows what.
Well, one example that I like is you always see people talking about this particular building that stood for 100 years, 1,000 years, whatever it be, right? Or Roman concrete being so exceptional. But they never seem to take into account the conditions that this device was in, or the fact that maybe this old house just so happened to be on a very, very stable foundation that they had nothing to do with in the original manufacture, right? You don't really take that into account. And there's a lot of that out there. You could design something that could last forever if it's not used or if it's tucked away in a little box somewhere hidden and never touched.
Or it happens to be in the perfect environment for that device.
Right, the exact perfect environment for it, right? Exactly the ideal conditions or how you designed it to be run. But the real task is making something that could be used in most practical environments or any environment and still last.
Yeah, that is difficult.
You don't see the house that fell down 300 years ago,
Oh.
right? You don't think about it. So this one example that survived for 1,000 years, that's great. But taking it apart and seeing how it was made doesn't necessarily tell you how to make one like that where you live.
Yeah, right. You'd have to go back to the original engineer designers and find out what their thought process was when they were doing it, and find out whether they were actually geniuses or whether they just lucked
It
out.
was just luck. Yeah,
Happenstance.
It's probably more than luck than anything.
probably.
I think.
Well, it's a combination of factors, probably.
Yeah,
They probably designed it to the best of their ability and lucked out.
yeah,
Yeah.
that's true. Yeah,
But most of them don't stand still.
yeah,
Only a few do.
right.
So ones that just so happen to be made in the right temperature, the right conditions, with the right mix of ingredients, and the foundation have to be in just the right whatever conditions so it was stable, and you didn't have to have a lot of activity in that area. There's a whole bunch of factors.
Well, its proof is how many of these, 1,000-plus-year-old stone things are still standing.
Well, most of them are.
Not many.
Not too many.
Well, I
Yeah.
think, and it was just like circumstance, because I know like the one area that they're making like really good concrete, it just the area had a lot of like pumice or
Uh-huh.
something in the soil, and that made it strong.
Yeah.
Yeah.
And that's what they had. So
Yeah.
that's what
That's
they used.
common, right?
It wasn't they were like super alien geniuses or
Yeah,
It just so
anything.
happened to work.
Just so
And,
happened that's what they had.
Right.
Yeah. In retrospect, you look back and
Yeah.
you think, wow, these guys were so smart, but they were just doing what everyone else was doing. It just so happened that the natural resources worked to their advantage.
Maybe it was really good pumice,
Well, it could be.
like better than anywhere on the planet for whatever reason.
Could be.
No one's looking at that. The molecular
Well, we are
makeup
now.
of the
Now
pumice.
we are. Now we can look at it.
Yeah. Or how they stirred it, or whatever, or what the temperature was when they mixed it. I mean, you think about all that's what you get down to, or you boil down to, is the whole process just matters. And they probably just lucked out. They lucked out when they built that one. It was a good year for
Foundations?
For foundations, yeah, it was a good year. So on that note, everyone, thanks for watching our blabber. Hope that kind of explains the intricate process of quality control from beginning to end, which there's a lot to cover there. If you really wanted to know the details, you kind of got to work here. But take care of yourself, everyone.